Hey Chemistry, this is KJ here going over Lesson 13, Properties of Substances. All matter has definite properties and can undergo chemical and physical changes. All around us, matter undergoes physical and chemical changes. In this lesson, you will learn about the physical and chemical properties of matter, how matter undergoes physical and chemical changes, and how to recognize and distinguish between these changes. Goals for the lesson: distinguish between a substance's physical and chemical properties, define and give examples of physical properties of matter, including mass, volume, and density. Describe and distinguish between physical and chemical changes in matter. Matter has unique physical properties and chemical properties. Matter undergoes physical changes as well as chemical changes. From slide 2, if you log into the lesson, you can get your study guide, which I just copy pasted and cleaned up a little bit and put into a Word document. Cooking breakfast involves physical and chemical changes. Consider cooking a breakfast of fried eggs, pancakes, toast, and hot tea. First, you pour pancake batter into a hot skillet. Initially, the pancakes are a slimy liquid. After a few minutes in the pan, the liquid begins to brown and turn solid. The pancake batter is not the same as it was before. Okay, I want to stop right there. Was this a phase change? The answer is no. For some reason, this trips people up. But think about it this way. If we are adding heat to a liquid, what is that liquid going to do? It's going to boil, right? It's going to boil and turn into a gas. But in this case, yeah, you do have some little boiling and there is some of the water vapor that escaped from the little bubbles. But overall, the pancake is turning into a solid. So you're adding heat and turning a liquid into a solid. That is a big clue that it is a chemical reaction and therefore not a phase change. Next, you put a slice of bread in the toaster and it turns from white to a golden brown or perhaps even black if you toast it too long. Again, it's not the same as before. You might even tear the toast in half before buttering it. Now, tearing it in half would be what kind of change? Physical, because it was toast before and toast after. But the bread to toast, that's the chemical. In each of these steps, you have observed either a chemical or a physical change in the matter we call food. Now take a closer look at what constitutes a chemical or physical change. Matter has physical and chemical properties. All matter has unique features that allow us to distinguish one type of matter from another. We call these features properties. Okay, so in really general terms, I can say we can tell this object is different from the background because it's white. The background is blue. That's a physical property. The bubbles are round, and this is a liquid that takes the shape of the container. Those are physical properties. So physical properties is a fancy way to say explain what it looks like, explain all about it. Properties can be classified as physical or chemical. A physical property is a characteristic of a substance that you can see without changing the nature of the substance. An effervescent tablet, for example, is solid and white. You can observe and measure it. We could also say that it's about an inch across, so we could use size as well. We could say how heavy it is. We could find the density. All that kind of data that you can find without changing the substance, all of those are considered physical properties. A chemical property is a characteristic of a substance related to its ability to interact with another substance. If you place an effervescent tablet in water, it will fizz and then dissolve. So the fizzing that's giving off bubbles tells you it was a chemical change. You can't get the tablet back. You have bubbles. A chemical reaction. Watch the video to see the chemical reaction that results when an effervescent tablet is dropped into a glass of water. So they dropped it in there. You can see the instant bubbles. And you can see that there is less and less of the tablet. You can also possibly see that there are some darker chunks once in a while. So something else is going on here besides the bubbles. And if you could hear it, it sounds like shh. So a lot of times sound is another indication that you have a chemical change going on. Physical properties are observed or measured. Physical properties are features that can be observed. Here are some examples. Mass. How much matter does a particular substance contain? Volume. How much space does the substance take up? Shape. Is it round or square, flat or fluffy? Density. What is the ratio of mass over volume? Or in other words, you take the mass divided by volume. It's kind of like how thick something is. State, is it a solid, liquid, or gas? Color or luster, what color is it? How shiny is it? So luster means that it's shiny. Hardness, how easily does it scratch other substances? Viscosity, how easily does the liquid flow? Viscosity is how thick a liquid is. For example, honey has a very high viscosity. Water has a very low viscosity. Odor, what does it smell like? Magnetism, does it attract certain metals? Solubility, how well does a substance dissolve in another substance? Freezing point, at what temperature does it become solid or melt? Boiling point, at what temperature does it boil or condense? The hardness and brilliance of a diamond are physical properties. So in our notes, I wrote physical property, a measurable or observable characteristic of an object or substance that can be observed or measured. So I have that in there twice. I'm going to clean that up real quick. All right, a measurable or observable characteristic of an object or substance. And then I just copy pasted all the examples. Sometimes it's good just to run through them. And also I kept this definitions on here. Feel free to keep them on. Feel free to just write the ones that you don't usually think about it. Remember, your notes are for you to do well on quizzes and tests. Physical properties help chemists identify substances. One important physical property is density, the ratio of mass to volume. So let's look at a few things here. Density is abbreviated capital D. Mass is abbreviated lowercase m. Volume is abbreviated capital V. Yes, the capital and lowercase is important because there are many things that are abbreviated. Capital M stands for something else. The formula for density is density equals mass over volume, where mass is measured in grams, grams are abbreviated G, and volume is measured in milliliters, abbreviated ml, or cubic centimeters, centimeters cubed. For example, 1 gram of water has a volume of 1 cubic centimeter, so the density of water is 1 gram per centimeter cubed. You can easily measure the mass and volume of an unknown substance and calculate its density. To identify the substance, you can compare its density to the densities of known substances. For example, the table shows that a solid metal with a density of 7.9 grams per centimeters cubed might be iron. So if we look here, we see 7.9 grams per cubic centimeters as a solid, and that substance is iron. Usually you need to know several physical properties to identify an unknown substance, although density is often used for this. So for example, if I said I found a rock and the rock has a density of 15 grams per cubic centimeters, did I find gold? Well, if I said it was 15, no, I didn't. It is in fact 19, and that's actually how they determined if nuggets that were found were fool's gold or gold, by looking at the density. All right, so to the notes, I made a chart. So I have our term, the abbreviation, and the units abbreviation, along with the unit. It is so important that you know the units that go with the term and you know all the abbreviations. We are going to be using these all year. You are going to be doing math problems all year. Yay! I know, you can't wait. And it will make it so much easier if you know your abbreviations. So density, abbreviated D. Volume, abbreviated V. Mass, abbreviated lowercase m. Density has a unit of grams. The unit is what comes after the number. So for example, I have 10 grams per milliliter. In math class, when you have a division sign, you read it per, as in P-E-R, not P-U-R-R like your cat does. So grams per milliliter, G/ml, or grams per cubic centimeters, grams per centimeters cubed. For volume, our units are milliliters for liquid and cubic centimeters for solids. And the way that they get this cubic centimeter is because the equation for volume is length times width times height. That gives you the cubic centimeter. For example, my length is 3 centimeters, my width is 2 centimeters, my height is 4 centimeters. I multiply 3 times 2 times 4 to get 24. And I multiply centimeters times centimeters times centimeters to get centimeters cubed. Just like in math class, x times x times x equals x cubed. That is also a very, very important thing to know in chemistry class. You can't forget your units. If you multiply stuff, you got to multiply the units. All right, 1 milliliter of water equals 1 cubic centimeter of water. So just kind of a fun fact that seems to come up now and then. Mass, abbreviated lowercase m, can be measured in grams, g, or kilograms, kg. And of course, density can be any combination of mass and volume. So I could have kilograms per milliliter. I could have kilograms per liter. Okay, so there's a lot more than this, but the ones I listed are the main units we will be using. Make sure you know them. The equation is density equals mass over volume. There are no math problems on this quiz. There will be later, but not on this quiz. However, you do need to know this stuff for the quiz. So there will be questions, but no actual math problems on the quiz. Physical changes do not change the composition of matter. Physical properties of substances can change. In the breakfast scenario, you boiled some water for tea. The water changed from a liquid to a gas, water vapor. That change in state is a change of physical property. Such changes are called physical changes. Remember that the molecules in water vapor and liquid water both have the same chemical composition. And what is it? H2O. So a physical change does not change the chemical nature of the matter. In other words, it's still H2O. It's just gaseous water, liquid water. You freeze it, you have solid water. It's still water. It's a physical change. Tea leaves are a solid. When you put the tea bag in the hot liquid, some of the chemicals in the tea leaves dissolve in the water. Yet those chemicals retain their chemical identity. Similarly, if you put sugar in the tea, the sugar is no longer a white solid, but it does dissolve in the liquid. The sugar molecules, however, remain chemically the same. So in other words, even though it dissolved and you can't see the sugar is still there. If you let the water evaporate, or you boiled the water, at the bottom of the container would be sugar again. Or at the bottom of the container would be the chemicals that came out of the tea leaf. But they're still the tea's chemical. It's still sugar. It's still C6H12O6. Therefore, it is a physical change. Other examples of physical change include melting, changing shape, breaking, and crushing. Sugar dissolving in water is an example of a physical change. Tea dissolving in water is another example of a physical change. And I added to our notes physical change, to change to a substance that does not alter its chemical composition. Examples, dissolving, melting, changing shape, breaking, and crushing. And of course, all of you should be singing right now at home, phase changes are for physical. I feel like I should give bonus points if you have like a 2-year-old brother or sister and you teach them to start singing it around the house. All right, that being said, you don't really get bonus points because not everyone has a 2-year-old brother or sister. I just found it amusing. All right, focus. Chemical properties must be observed by detecting chemical changes. In contrast to physical properties, you cannot see chemical properties just by observing a substance. You can only determine them by observing if the substance undergoes a chemical change, a change that produces matter with a different chemical makeup from the original matter. For example, when you strike a match, the wood burns, consumes oxygen, and gives off light and heat. The wood in the match changes to charcoal, carbon, which is not the same chemical form of matter as the original wood was. Specifically, the cellulose in wood has changed or reacted with oxygen to produce carbon, water vapor, and energy. So flammability, or the ability to burn, is a chemical property of wood. Okay, so while you know that yes, wood can burn, you can't actually see the burning unless it's actually doing the chemical change. So that's what it's talking about. When you broke the eggs to fry for breakfast, they were liquid with bright yellow yolks, but when cooked, they changed chemically into white solid instead of the clear liquid with solid yellow yolks. Again, not a phase change because we added heat and we went from liquid to solid. So that's a big indicator that it was a chemical change. Such chemical changes transfer the composition of the original matter into new matter. So in our notes, chemical change, change that results in the formation of one or more new substances. Chemical property, a property inherent in the chemical makeup of a substance that is revealed during a chemical change. In other words, you know wood is flammable, but you can only observe or see it when it is undergoing the actual chemical change of burning. Chemical changes occur when substances interact with each other. When the iron nail